read loud. And all these things were added. All these were added by ChatGPT, and so we should be very careful that the added information is really needed by me or not. If suppose this was any American, it was just a fun, but if you are doing some serious business and you are writing an academic research paper or thesis, and you are making use of ChatGPT, it might be adding certain things which you might be out of context to you, and you will not feel, because it will be having a large chunk of words, and will not be able to figure out that what is relevant here. So one should be very careful when he or she is using these tools of artificial intelligence. What actually the suggestion is that there are three possibilities of use about AI. One possibility is that we say, okay, we as a principal of the school, or chairman of the department, or vice chancellor of a university, or the teacher of a class, we strictly instruct that nobody will be using AI tool, because it will be dangerous for learning, because people will not learn themselves, and it will diminish their knowledge. So we should put a ban on using artificial intelligence. It was done by some board of educations in America, in Maryland and other places, in the early days of these, in the last 2-3 years. So, but they abandoned that, and they realized that they cannot stop the fast speed through which this AI technology is entering the society. So you cannot stop. You cannot stop, and it is there, and the students will be using it. Now we'll have to be careful that how can we cope with this challenge, this new challenge. I mean, as a teacher, as a researcher, these are two situations of us, that we are the teachers and we are the researchers. I gave you the example of, as a researcher, that you are taking help of ChatGPT for writing some document, and I have shown you that what it is, how it is affecting your final product. But as a teacher, you have given some assignment to the students, and they took help of ChatGPT or any other AI tool, and they did it without putting their own labor. So at the end of the day, they will not learn anything, and they will remain ignorant, completely ignorant about their topic, and so it is danger for the process of studying. So how can we tackle this challenge as a teacher? As I said, that there are three approaches towards AI. One approach is that we can give all our work to AI. I can outsource it to AI, and we just relax. But if we adopt this approach, at the end of the day, we will be loser, because we will not be gaining knowledge, and we will forget what we have learned so far. Third possibility is that we just abandon it, and we declare it as that we should not touch this, and we are not making use of it. Again, it is not advisable, because a thing of use is there, and it has many positive aspects. So why should we deprive ourselves or our students from this new tool of knowledge? So the third possibility is that we should learn along with AI. Learn along with AI. I mean, we should be, neither we are imposing AI on us, nor we are rejecting AI altogether. We are learning along with AI. So what my suggestion is that use artificial intelligence intelligently. If we are using artificial intelligence with intelligence, then we can succeed. And now in the classroom, we have to change our style of teaching. The reason is that the student carrying a mobile in his or her pocket has tremendous amount of knowledge, not knowledge, information, I should say. Tremendous amount of information is there stored, and it is quickly and intelligently retrieved by these AI tools. So a student in the class has this misunderstanding that he or she knows more than the teacher who is standing in front of her or him. While the truth is not. Truth is that the information is stored in that mobile. It is not there in the mind of a student. The student is still ignorant. The only thing is that he has a storage device with vast knowledge. So that vast knowledge or storage device, having vast knowledge in a storage device doesn't make any person knowledgeable. The knowledge is what we retain in mind after reading the book, after doing a course on the subject of study. That is the knowledge. So the knowledge should be with us, in our mind, not in our pocket, on a storage device. So what we should do to tackle this challenge, that we should start interactive teaching. Because when you are interacting with a student, you are asking a question, you are giving an activity in the class, and then you are doing them to do it. Then when they are doing, or if you are asking them to do it on the blackboard, then their own skill will come out. There they cannot take out the mobile from their pocket. There you are really involving them in learning something. And then the student will not be able to do it. He or she will realize that he or she needs to learn it. Now he is free. He or she can take help of AI. That's what I'm saying. Along with AI, learn along with AI, not depend on impose AI on us, not abandon it. Anyway, so this is the way that we can make AI as a tool of learning rather than a tool of ignorance or an abandoned thing. So with these brief comments on the use of AI, let's go back to our continuity on this. So that's these 2 points I had to touch simply. The third aspect, which I promised in the beginning, was the quantitative aspect of research. Quantitative aspect of research, when we are conducting any research project, most of the, I should not say any, but most of the research projects requires that we should have a quantitative support to our conclusion. Best example is that if suppose we are feeling that we have we are feeling feverish. The body has our body has feeling feverish. So what we'll do? We'll say that, okay, I am feeling feverish. Somebody will touch our hand and say, yes. No, you don't have fever. No. Other person will come and say, no, yes, you have fever. So now this debate will end if you put up a thermometer and the thermometer decides that we have 100° Fahrenheit temperature. So that stops the debate of qualitative statements. So whenever we are making any statement, generally it is a qualitative or in the form of subject, in the language. But we append to it to make it more powerful, more understandable, more reliable. We add quantitative support with our statement that I am feeling feverish and I have 102° Fahrenheit temperature. That makes complete. Now, this statement is complete, and this will not have any debate. Everybody will believe this thing. So the beauty of this statement is that I am feeling feverish. It is a qualitative statement, and to support this, we have said that I have 102-degree Fahrenheit temperature. So that quantitative support to this a quantitative statement completed this whole information as a reliable and acceptable information in today's world. This is a very simple example from our daily life. If we take up it to the larger scale, the research project which we are carrying, whatever the conclusion a researcher is drawing from his or her thesis or dissertation or from research paper, that conclusion will be accepted by the academia if it has a quantitative support, or you can say we can provide the data support to it, and the proper statistics is developed for it, then only we will accept it. So how and what we do it, I simply give example that if suppose we are doing research in, say, education, and from somebody is from education department, and there is a new curricula is adopted by say some board and for the schools, and the researcher wants to see whether this curricula has helped the students in understanding the subject better as compared to the old curricula. So to compare these two, there will be a can say a hypothesis, or in Hindi we say parikalpana, or in Urdu it is mafruza. In English it is hypothesis. So a parikalpana, a mafruza, a hypothesis is there in the mind of the researcher, that he or she will say that, okay, this curricula is more helpful to the students in understanding the subject. Or from agriculture, somebody is saying that this new irrigation facility of the farmers is helping in giving them more yield. Or if there is a doctor, I mean, he's giving, say, some new feed to the fish from fisheries research, and he says that now the fish are gaining more weight through this new feed. Or some agriculture man is there, he says, saying that I have developed a new seed, and this seed is giving more yield to that particular crop. So all these are statements or assumptions of the researcher, which he or she has to justify by collecting real data from the research field of the researcher. That real data or statistics will lead the researcher to a conclusion in favor of his or her hypothesis or against of that. So that completes a modern research work, whether it is a PhD degree research work, or it is a research paper, or is a project. So we will find ourselves collecting the data. So I am not going to, because in this short talk, I cannot cover the entire subject of statistics. But I will touch upon few points which are either misunderstood or generally required to be understood by the researcher. Let's begin with this. What is the definition of statistics? Which is quite familiar. Statistics definition is it is collection, presentation, analysis, interpretation, and a systematic collection of data on measurements or observations. It may be population counts, incomes, population counts, or different ages. Population. The word population is a technical word of statistics. It doesn't mean that population means the collection of human beings. Population can be the individuals or entities on which the researcher is doing the research. So we should be using the word population in that sense. You can think what population in your research area is. you might have thought about these research areas in your the population in your research areas. If suppose you are doing research on education, so the students of schools would be the individuals or the population of students. If somebody is doing research on fish, so that fish will be the population. Somebody is doing the research on trees, so that trees will make the population. Anyway, so the population is the collection of individuals on which the research work, the study is being done. And this is another definition. Statistics is a branch of mathematics concerned with collection, interpretation. So main thing is collection, interpretation of quantitative data. And it makes use of the probability theory to estimate population parameters. Population parameters means, say, for example, mean of the population, simple example, mean of the population, say average weight of fish, can say average marks of students in a subject. This kind of population parameters are to be estimated. Another definition of statistics, which is generally not used, but it is, and that is statistics an art and science of collection, compilation, etc. So, I mean, statistics is science, but for researcher, it is an art also, because if suppose you are an artist and you have a pen, colors, a collection of colors is there with you. Different sizes of brush are available to you. Now, the choice of the right color and the right brush and the right theme, that makes an artwork different from another artist. So, collection of knowing the availability of the tools is not sufficient to do the research, but the real thing is that if you know the art of using the real tool, right tool, if you have a hammer and you have a screwdriver, and so you will have to decide that whether I should use hammer here or a screwdriver here. If we are fixing the nail with the screwdriver, we'll be wasting time. Or if you are using hammer to fix a screw, then we'll be damaging the screw. So basically, an artist should know that which tool to be used. So a researcher should, and art is always learned in the company of an artist. So swimming is always learned with a swimmer. Music is learned with a musician. You cannot learn it without these experts. So my humble suggestion would be that whenever you are starting a project of research, and if you feel that there is going to be a component of statistical analysis of the data there, before starting the project, we should consult a statistician, or you should have yourself the knowledge of statistics sufficient for carrying out that project. Without that knowledge, we will not be able to do the justice with our research. So, because I made the importance of it, because of we can access a research a software which is providing us the formula for mean, median, mode. But here in this particular situation, should I use mean or median or mode? That will be decided by a statistician. This is simple example, but you can think of different statistical analysis tools are available. When you become, if you go to higher, you suppose discriminant analysis, whether you are going to use coordinated discriminant analysis or linear discriminant analysis, or you are going to use multiple regression or simple regression, and that kind of questions may come up at the time of analysis of the data. So that analysis should be planned in advance, and for that analysis, the data should be planned, that what data is to be collected, and collection scheme like the sampling or sensors, these collection schemes should be decided. So we have to define the population. We have to define the population is defined in the light of our research hypothesis. So we'll touch this research hypothesis in detail. I just skip this. I skip this as well. Okay. So data are the facts and figures collected, summarized, analyzed, and interpreted. So data collected in a particular study is referred as data set. So we will be collecting data, and that will make a data set for our research work. And we would be collecting the data on some elements, the entities, the individuals of the population. So, and the characteristic which we are studying, that we call variable. So suppose we are studying the marks of students, or suppose we in another study in the fisheries research, we are studying the weight of fish, or we are suppose we are doing the research in forestry, we are studying the timber, you can say quantity of wood in a tree. So that can think of many variables on elements, and the value which we get for a variable from an element, that is called observation. So the set of measurements collected for a particular element is called an observation. So these are the basic terminology: elements, variable, and observation. So the total number of data values of a data set will be the number of elements, the number of individuals in your population multiplied by the number of variables. So that and when you are taking the measurements, I just skip this. When we are doing the measurements, these are the four possible scales of measurement: nominal, interval, ordinal, and ratio. I hope that you would be knowing it. And actually, these should be known. It should be very clear in the beginning because of its utility in the at the time of analysis. I just skip this. I hope that you would be knowing this. So I just skip. This is again in statistics. You might have come across these two terminology: discrete and continuous. And discrete and continuous, actually, the answer of how many is discrete, and the answer of how much is continuous. And quantitative data is always numeric. And when we have quantitative data, we are having a large number of tools available to us. But if we have qualitative data, we have little, a lesser number of tools available for us to analyze the data. So this is that gives you a clear picture. The data can be either qualitative or quantitative. If it is qualitative, then it can be numerical, non-numerical. Within numerical, it can be nominal, ordinal. Nominal and ordinal can also be non-numerical, but quantitative data is always numerical, and it can be either interval scale or ratio scale. I skip this as well. Okay, data sources for researcher. We have experimental in the studies. We have to identify the variables of interest in the beginning, and we'll take some factors to be controlled and others to vary, so that we can study the effect of variables, influence of one variable on the other, or a group of variables, or that kind of, influence of the variables we can study. So that is experiment study. For example, you are, some agriculture scientist is there, and he is giving same irrigation, using same irrigation facility, same fertilizer, to study different varieties of seeds. So now he has maintained some variables common, like same irrigation facility, same fertilizer, only changing the seed. So that will give us the effect of seed on the final crop, final harvest. So this way we can plan is experimental study. Or we can have observation studies. So a survey is the best example, that you are the things are there in advance. You are not creating the data. The data you are collecting from observations. For example, you are going to ask the people their opinion about something through a questionnaire or through a schedule. So this is a survey data, and that survey data is actually is an observational or non-experimental study. So a survey data is collected through various means. You can have a telephonic survey, you can have survey through email, you can have survey through questionnaires, you can say the Google form. There are many possibilities are there for collecting the survey data. You can do the interviews physically. One investigator contacts the individual in the population, and they can collect the information. So these are the data sources. For researchers, these are two possible examples: experimental or observational study. Sometimes we are studying like this, that we are going to a village and we want to find out that what is the holding of land by per household, and how many tractors are there, how many you can say pakka house, kacha house in a village. Like this, you are observing this, collecting the data, not the opinion, but you are collecting the data, the existing availability of the data. That you can do. But all these are observational. So observational studies. Another aspect of is data acquisition. These are basic constraints, can say considerations. When you are collecting the data, the time requirement is very important. That time is a cost. Time is limited to us. So we should be careful about time management in collecting the data. For example, if somebody is predicting the election results, so the limit, the time available to the researcher is up to before the declaration of the result. Because if you are predicting the possible results of a research, of an election, that is useful only before the declaration of the result. So time requirement, cost, again, when collecting the data requires some money. That cost is also limited. So we'll have to keep in the mind that we should be within the limits of the available funds. And the errors. The errors, remember there are two words in English: error and mistake. Here, error is a technical term of statistics. Mistake can be rectified, but error will always be there. It can be minimized by using statistical techniques, a proper technique. We can minimize the errors. So errors are, again, is a topic of a study of statistician, how to minimize the error in the collected data. I skip this, people know it. Now, this is the thing which I have to, I will spend more time on it. Developing null and alternative hypothesis. Hypothesis with I is singular, hypothesis with E is plural. So, as I said in the beginning, that hypothesis is the statement about the population parameter, which is set by the researcher in the beginning. Now, these are two types of hypotheses: null hypothesis and alternate hypothesis. Generally, a misconception is there that I want to clarify in here. Generally, we write null hypothesis and alternative hypothesis, but which one is written first? Anybody? Can you tell me which hypothesis will be written first? Null or alternative? Null. Any other? Null is written first, or any other response? Which hypothesis is written first? Generally, this is the knowledge that people always answer it like this: that null hypothesis is written first. This I want to clarify. Actually, the books which we are reading in India, these on statistics, these books are generally written with a view that the reader of the book is from commerce background, because they constitute majority, or business background, business studies background. So in that situation, there are two interests. One is of manufacturer interest, and the other is a consumer interest. So manufacturer risk or consumer risk. So what we do in these business deals, manufacturer has a claim. Say, for example, manufacturers made a claim that this water bottle contains 500 ml of water. It is written on the bottle. We give, and we want to study whether the supplied bottles contain the amount of water written on the bottle or not. So for that, we give benefit of doubt to the manufacturer, and we accept his claim as a null hypothesis. And we say that average water in the bottle is equal to 500 ml. That is our that is our statement, and that null hypothesis is formed. And opposite to this, we say no, it is less than that, it is greater than that, or not equal to that. That we are saying as an alternative hypothesis. So this is in the environment of business or with manufacturer and a consumer scenario. But here we are talking as a researcher. As a researcher, if you feel that which hypothesis is written first, let me just think that how the research starts. You have a hypothesis in your mind, which you say research hypothesis, which you want to establish. Say, for example, you want to establish that the new curriculum of education is more useful in spreading in knowledge as compared to the old one. So this is the hypothesis of the researcher from education department, or a researcher from fisheries saying that this feed is giving more gain in the weight to the fish as compared to the old feed. So it is a claim, or it is a research hypothesis. So in case of research hypothesis, it is, and researcher wants to establish this. So in null and alternative pair, the things which is established is the alternative hypothesis. So alternative hypothesis ultimately is established, and that is the target of the data analyst. So we, the researcher, should write the alternative hypothesis first. So research hypothesis is alternative hypothesis, and that is the first thing which come up to the mind while we are even starting the PhD or thesis or the research paper. So in research scenario, alternative hypothesis written first, and then opposite to it is null hypothesis. This I wanted to clarify. It's a general misunderstanding, and I picked up this topic so that I clarify this, and I'll explain you further in this. So null and alternative hypothesis and type 1 and type 2 errors. These different situations are there. Population. We are conducting a test where on population mean. Under the situation sigma, the standard deviation is known. Under the situation sigma is unknown. Okay, let us see developing null and alternative hypothesis. So we are having a statement about the population parameter, and that what is written in the null hypothesis, we want to reject it. And for that, we are saying that it is a null hypothesis, it is a tentative assumption. It is a tentative assumption about a population parameter. Remember, this is a tentative assumption. Tentative in the sense that until our test of hypothesis completes, it is there. But at the end of this analysis, we may conclude whether we reject it or we do not reject it. Once it is rejected, what will happen? Alternative hypothesis will be established. So the alternative hypothesis denoted by H1 is the opposite of what is stated in the null hypothesis, or vice versa. And alternative hypothesis is also often what the test is attempting to establish. So statistical, a test of hypothesis will, we try to establish alternative hypothesis. So in the research scenario, research hypothesis should be expressed as the alternative hypothesis. And the conclusion that the research hypothesis is true comes from sample data and contradict the null hypothesis. Once the null hypothesis is contradicted or rejected, alternative hypothesis is established. Now just see that here we are saying comes from the sample data. So what actually happens that you, as a researcher, you have a research hypothesis that we have translated as alternative hypothesis. Then opposite to that is written as null hypothesis. Now we have a combination of null and alternative hypothesis. To test this null hypothesis, we have some standard statistical tests, which you call test of significance. And for that test of significance, we have a test statistic. I'm not using statistics, I'm saying statistic singular. For testing this null hypothesis, we have a test statistic. That test statistics requires some statistical constants from the sample from the population. So we will have to decide that what null hypothesis is there, and that combination null hypothesis requires which test statistic, and for that test statistic, what statistical constants we need from the sample. For that sample, how to get that sample, and how to correct the sample, and how to use this sample in our test statistic. So this is, as I said, told you that the manufacturer, I just skipped this, I have already discussed this. Again, this is, okay. There are three situations in test of hypothesis. If suppose we are testing the population parameter is mean, population mean mu, we are testing that. So there is one combination that we have null hypothesis that mu is greater than or equal to mu naught. Mu naught means a specified value of population mean. The population specified value, we are saying in alternative hypothesis that population mean is less than the specified value. Opposite of this is in the alternative, in the null hypothesis, that is no, population mean is greater than or equal to specified value. Second possible combination is that we are saying in the alternative that population mean is greater than the specified value. And opposite of this is in the null hypothesis that no, population mean is less than or equal to specified value. And the third and the last possibility is that we are saying that a population mean is not equal to the specified value. Rather, opposite to it is that no, population mean is equal to the specified value. From statistical theory, we have named them one-tailed, one-tailed lower tail, one-tailed upper tail, and two-tailed tests. These are actually because of normal distribution has two tails, and one on the left side, one on the other side, and at middle at the zero, z is equal to 0. This is it creates symmetry. If you put a mirror, you'll find a mirror image on both the sides. So the test can be one-tailed or two-tailed. I just skip this. Okay, the type 1 error as I told you, that there are two types of errors, and error can be minimized. And that minimization of error, we have some statistical tools. So, and why these errors comes up? Because our hypothesis is tested using the sample data. And sample data may have some genuine errors. Genuine errors means that not created by the person who is collecting the data. For example, if suppose you are a very honest person and you conducted a sample survey in a university environment for estimating the average salary of university employees. And suppose out of 8,000 employees, you have took a simple random sample of 100 employees, and it may happen that you may get most of the individuals, the sample collected by you, professors. So your average will be very high. On the other hand, another researcher, he or she came and they collected the data, and they had more fourth grade employees in their sample. So they may have very low average. So this kind of possibilities are there because of genuine sampling errors. So ultimately what will happen that we will reject H0 when it is true. So this we call it type 1 error. So what we do, that the probability of making type 1 error is called the level of significance. So that's why these are called significant tests. And this level of significance, you might have heard 5% level of significance, 1% level of significance. So that level of significance is set by the researcher in the beginning of analysis. So type 2 error is we are not rejecting H0 while it was false. So if we are not rejecting H0 while it was not false, so that is type 2 error. So it is difficult to calculate the probability of this. So what we do, that we control it. So we control it by using probability theory. So these are the four possibilities of rejecting H0 and not rejecting H0. If we rejected H0 when it was false, it is a correct decision. But if we reject H0 when it was true, it's type 1 error. If we did not reject H0, it was false, it is type 2 error. We did not reject H0 and H0 was true. We did not reject H0, and while H0 was true, so it is correct decision. So in this way, this is a possibility. Okay. Another basic concept is p-value. We use p-value, but a good majority of us do not understand what the p-value is. Here you see one example. P-value is a probability computing the test statistic that measures the support or lack of support provided by the sample for the null hypothesis. So this is the formal definition of p-value. And the general rule is that p-value is less than or equal to the level of significance, the value of the test statistic in the rejection region. So what is the general rule? General rule is this. Oh, sorry. Reject H0 if the p-value is less than or equal to alpha. Alpha is the level of significance. So this is the general rule in the testing of hypothesis, that reject H0 if the p-value is less than or equal to alpha. So most of you might be knowing it. The thing which I have to clarify here is just see it. Here we are taking a situation where we are testing population mean, where under the condition that sigma is known to us. For that, we have a test statistic called Z, and it is x bar minus mu naught upon sigma upon square root of n. Here, mu naught is specified value of population mean, and that is known to us. Sigma is also known to us, but x bar is the sample mean and small n is the sample size. These two quantities are coming from the sample. So when we are substituting these values in this formula of Z, we get that, we say that it is the value of Z from the sample, or you can say calculated value of Z. At the same time, we have from theory of probability, we have the values of Z available to us in the form of tables, which are arranged with alpha value. So suppose we have decided that level of significance will be 0.1. So alpha is 0.10. The corresponding value from a table of Z is minus 1.28. Now, you can see a vertical bar here, and that vertical bar is dividing this whole region into two. On the left of it is the rejection region, on the right of it is the acceptance region. So if the value of Z, calculated value of Z, lies in this region of rejection, we reject null hypothesis. On the other hand, if the Z values lie on the other side, then we do not reject H naught. Okay? Suppose the Z value which you calculated is minus 1.46, which is being minus value is less than minus 1.28. So it is less than the, the corresponding p-value from the table for minus 1.46 is 0.072. So because 0.072 is less than 0.10, we reject null hypothesis. Now here a question is that this value 0.072 has made the rejection of null hypothesis. If suppose if this p-value would have been 0.002, it would be lesser than alpha, and the hypothesis would have got rejected again. So what is the difference between these two rejections? Both are rejecting null hypothesis, both are accepting the establishing the alternative hypothesis. Alternative hypothesis means the researcher hypothesis. But what is the difference between establishing with 0.072 or establishing with the 0.002? What is the difference? Anybody? What is the difference with if hypothesis rejected with p as 0.072 or p as 0.002? Any idea?
In 95% confidence interval, 99% interval.
No, that thing will not be here. It is the interpretation of P. If we know the correct interpretation of P, then we can answer this question. What P is equal to 0.072 interprets? What P is equal to 0.02 interprets? Actually, as it is all depend on the sample. So what actually we are saying, that if you repeat this experiment 1,000 times, only in 72 cases, our conclusion may go wrong. But in 928 cases, our conclusion will remain valid. If suppose P is equal to 0.002, then the interpretation would be that in 1,000, if you repeat this experiment 1,000 times, only in 2 cases, our conclusion may go wrong, but in 998 cases, our conclusion will be true. So lesser the p-value, stronger the conclusion. Got it?
Yes,
lesser the p-value, stronger the conclusion. So a p-value is very useful it is used for deciding about the null hypothesis. At the same time, its value will be an indicator whether we are it is a strong conclusion or a weak conclusion. Okay. That was this is upper tail test. Here we are seeing the value on the right side. In the previous one, we were seeing on the left side. It was lower tail test, and this one is upper tail test. We are seeing the value on the right side. Here again, we have to say alpha is equal to 0.04, and the table value which is available in the books, that corresponding to 0.04, the value of Z is 1.75, and from some sample, suppose we are getting the value of Z is 2.29. So here, P value corresponding P value is 0.011. 0.011, P value is greater than or less than 0.011 is greater than and is less than 0.04. So reject null hypothesis. So again, the same procedure of rejecting same rule that we reject H naught if P value is less than equal to. There is another approach which is called critical value approach for one-tailed hypothesis test. In this brief background of it is that test statistic Z has a standard normal probability distribution. And we can use standard normal probability distribution table to find the Z value with an area of alpha in the lower upper tail of the distribution. So this is called critical value approach. So what we do, that we find the value of the test statistic that establishes the boundary of the rejection region, and it's called critical value for the test. I mean, critical value means which is dividing the region into two parts: rejection region and non-rejection region. So reject H naught if Z is less than or equal to minus Z alpha. Now we are not using p-value approach. Here we are using critical value approach. So critical value is obtained, and that critical value is compared with the value of Z which we have computed by using sample data. And we compare this Z with the table values which are available. So we say critical value, and we are using critical value, and we are comparing with the table values. So here you don't have a uniform formula like that, reject H naught if p value less than alpha. But here you will have different criteria. For example, reject H naught if Z is less than or equal to minus Z alpha. And upper tail test, reject H naught if Z is greater than or equal to plus Z alpha, right? So this is a difference between critical value approach and p-value approach. This is an example of critical value approach. Here we are doing the lower tail test about population mean, and the assumption that sigma is known to us. Again, the sampling distribution formula, or you can say test statistic Z is x bar minus mu naught upon sigma upon square root of n. Again, the specified value of mu 0 is from the knowledge, and sigma is again from the past knowledge. Only sample values are providing us sample mean and the sample size. And we are getting this corresponding value for alpha 0.10. The Z value is coming out to be -1528. And we do not reject H0 on the right side, and we reject H0 on the left side of this critical value. So this critical value is this. We have to compare our Z value with the critical value. In the upper tail test, it will be on the right side. The same theory, the same thing. The only thing that we are seeing the right side of the critical value rather than seeing the left value in the lower tail test. Here in the upper tail test, non-rejection region is on the left side and rejection region on the right side, the critical value. Okay, so just let me summarize that if you are conducting a test of hypothesis, first you'd have to develop the null alternative hypothesis. As I told you that you have to specify alternative hypothesis as the research hypothesis, and opposite to that, you can write null hypothesis. And we'll have to specify the level of significance in advance. And then we have to collect the sample data as required by the test statistic. And once we have done these 3 steps, the final step would be that we will be using p-value approach, and we will find the value of the test statistic by using sample values, and we will find the p-value from it. And we reject H0 if p-value is less than or equal to alpha. So this is the 5-step procedure for conducting a hypothesis testing. In this process, we'll have to develop alternative hypothesis, we have to define the level of significance, and we'll have to decide the sample scheme, sampling technique, which we are going to use for collecting the sample data. And under that is sampling procedures, or you can say sampling design, which we are going to adopt. We'll have to have different sampling techniques. There are simple random sampling, stratified sampling, cluster sampling. There are many sampling techniques. And again, within the sampling, we have different ways of collecting the data. Suppose it is a survey sampling, then we have the questionnaire, we have interviews, so we have a schedule. So we'll have to decide that whether we are using the schedule, or we are using the questionnaire, or we are using interview, or we are using other means. This we'll have to decide, and using that sample data, we'll have to compute the test statistic, which is test statistic is dictated by the pair of null and alternative hypothesis that decides that which test statistic is to be used. And then this is the general rule that we use the p-value approach. I hope that the time is there for questions and answers and comments. And now I open it to you for the questions. Yes, if you have any question, please. Yes. Any question, comment?
Sir, what is the difference between parametric test and non-parametric test?
Oh, as I told you that the basic definition is the population, and population, and the second technical word is sample. So population, we have statistical constants related to population are called parameters, and statistical constants related to sample are called sampling estimates. So for example, population mean is denoted by mu, and sample mean is denoted by x bar. So when we say the word use population, a statistician will try to model this population by using a probability distribution. Say, for example, we use the terminology that this population follows normal distribution, or this population follows the Poisson distribution, or this follows binomial distribution. So when we have stated this kind of statement, it means that we are saying that the data from this population can be modeled by using the standard formula of normal distribution or binomial distribution or Poisson distribution. And these distributions are defined by some parameters. Say, for example, population normal distribution is characterized by two parameters, mean and standard deviation. And Poisson distribution is characterized by one parameter, the lambda. Binomial distribution is characterized by two parameters, n and p, likewise. So if we are, generally the tests are based on the assumptions of the population, and they follow some parametric distribution, and we are using the population parameter. But generally it is with the larger data set. We have smaller data sets, and sometimes even in the larger cases, we have certain tests which are not dependent on these parameters. So these are called non-parametric tests, such as Wilcoxon-Mann-Whitney's test and rank test. And there are many tests where we are using, we are not using these standard parameters of standard distributions. We are using some other techniques, say rank test, run test, and random test. So there are many. So one is parametric, and the other is non-parametric.
Thank you, sir.
Any other question? Yes. Has anybody used AI? And if it is, which tool of AI they have used?
Gemini.
Gemini. What was your experience?
More or less satisfied, but
Okay.
yeah, more or less satisfied.
Right. But actually, any technology is used with caution. So here the caution is that use artificial intelligence with intelligence. That's my statement.
Yes, sir. That's the point.
I have a question. What is the degrees of freedom, sir?
Oh,
When
degrees of
yes,
degrees of freedom. Actually, if you have x1, x2, xn, the data points, so you have n data points, n data values, you can say. If you are putting a linear constraint on it, so that constraint is limiting its freedom. For example, if you are saying x1 plus x2 plus x3 is equal to capital N, for example. So it means that you impose one condition. You are free to choose any value of x1, x2, x3. But if you say no, x1 plus x2 plus x3 should be equal to 1, and n. So you have imposed one restriction. So now your freedom was 3, now it has been reduced by 1, so 3 minus 1, 2. So technical definition is the number of linear, and the n minus the number of linear constraints, and n minus number of constraints imposed on the data. That is the reason.
okay, sir.
In chi-square test, we put the restriction that summation of observed frequency is equal to summation of expected value, expected frequency is equal to n, that kind of thing.
Okay, sir.
Right? If you don't have question, let us conclude it. One more thing which I wanted to add here is that, as I said it in the beginning, but I want to emphasize this, that in research projects, statisticians should be consulted well in the beginning of planning the research itself. Generally, what happens is that people come towards the end. They have a data in their with them, and they say that, okay, please do the significant test for it, or they go to some. They themselves start using. I mean, nowadays people have access to software packages, so they started doing themselves without knowing underlying assumptions, whether the data is fulfilling the assumption or not, and they are applying a test on this. So whether that particular test statistic is to be used there or not. Say, for example, certain test requires that the data, the underlying population is normal, and the fact is that the underlying population is not normal. And if you use it against the assumption of the test, the conclusion may be misleading. So the assumptions of the tests are to be fulfilled by the data. If that assumptions are not fulfilled and one has used the statistical tool, that will not do the justice. For example, the best example is this mean median mode, which everybody understands. Suppose somebody is making shoes, and he has the data of shoe sale in terms of size of the shoe and the number of pairs sold in the last 1 year. So he wants to know that which particular shoe he manufacture so that he get more profit. So in this situation, neither mean nor median will do the justice. It will be the mode. So instead of mean or median, the data analyst should find the mode that which size had the highest frequency of sale. That will be that will decide the question of manufacturer. So likewise, there are situations where we have simple regression or multiple or logistic regression. Which regression we have to use? If suppose we have one variable which has two possibilities, and that possibility depends upon many variables, and this one variable is to be predicted. See, for example, cured or not cured, cured or not cured. Now this is a binary. Now in this situation, logistic regression will be more recommendable rather than any other tool. So again, and sometimes the type of the scale of the variable that also plays a very important role. If the data is ordinal data, we have to use the ranks. If suppose you are having the ranks and you are using some other statistic than rank, other than I mean this is the ordinal data. Rank is ordinal data, and you are using some techniques which are assuming that the values are in the ratio scale. Then it will be misleading result. So these hidden assumptions of the data are to be checked by a good analyst before indulging in the real analysis and leading to the real conclusions. So that is a very important aspect. On computer programs which are available to researchers these days, they are dumb machines. Whatever the data you put in, some result will come out. But whether this result is really relevant to you or not, that will depend on the understanding, interpretation, understanding of the data, assumptions underlying in the data. In the light of these two, using the proper statistical technique and after getting the quantitative results from the technique, we have to interpret those. And that interpretation is again a challenging task. And that should be done again by an expert of the field. If we are not having an expert of the field with us, then we may give some wrong conclusions. I just gave you one example here of p-value. That we have the p-value, but very few researchers correctly interpret it. And if you are not using the right interpretation, if you don't have the right interpretation in mind, you may not be able to present forcefully the very good conclusion of yours. Your conclusion might be very strong, but you are not realizing its strength. And to present its strength, you may say that since the p-value is very low, it is 0.00001, it is highly significant. Now the word highly significant you are using because of low value of p, right? Otherwise, a 0.001 or 0.0001, both are leading to same conclusion. The only difference is in interpretation of highly significant and significant. The word highly significant you can use when the p-value is very low. So this kind of understanding could be used while using quantitative data. Okay. Thank you very much for sparing the time and having this discussion. I hope that you may use cleverly and diligently the quantitative and qualitative tools of statistics and artificial intelligence. I wish you all the best. Thank you very much.
Thank you very much, sir.
Thank you very much.
On behalf of UGC, MMTTC, AMU Aligarh and collaborating institute, Qazi College, Malda, West Bengal, I would like to express our sincere gratitude to you, sir, for your insightful and engaging lecture on overviews on the very important topic that is research excellence. Sir, your depth of knowledge and ability to present complex concepts in such an accessible and thought-provoking manner was truly commendable. The session was not only enlightening but also highly inspiring, providing valuable insights that will greatly benefit the participant in their academic and professional journeys. Sir, we deeply appreciate the time and effort you dedicated to sharing your expertise with us. Sir, your contribution has undoubtedly enriched our learning environment, and we hope to have the privilege of welcoming you again in the near future. Once again, thank you very much, sir, for your valuable contribution. Thank you very much, sir.
Thank you.